The computer, a device so ubiquitous today that it seems to have always been with us, yet its story is a recent one, a blink of an eye in the grand timeline of human history. In the 1940s, the world's first electronic general-purpose computer took shape, forever altering the course of human progress. This marked the beginning of a technological revolution that continues to accelerate at an astonishing pace. Our journey begins with the realization of a fundamental human desire to create machines that can perform calculations faster and more accurately than any human ever could. Early attempts, like the mechanical calculators of Pascal and Leibniz, laid the groundwork for the digital behemoths to come. These early machines, while impressive for their time, were limited by their mechanical nature, their speed, and their complexity. The true breakthrough came with the advent of electronics. Vacuum tubes, devices capable of controlling the flow of electricity with incredible speed, became the building blocks of a new era. These fragile glass tubes, glowing with an eerie, almost magical light, held the key to unlocking unprecedented computational power. World War II, with its insatiable demand for complex calculations, provided the impetus for this technological leap. It was against this backdrop of global conflict that the ENIAC was born. The Electronic Numerical Integrator and Computer, or ENIAC, was a machine of unprecedented scale and complexity. Housed in a massive room at the University of Pennsylvania, it sprawled over 1,800 square feet, its sheer size a testament to the ambition of its creators. Over 17,000 vacuum tubes flickered within its metal frame, consuming vast amounts of power and generating an immense amount of heat. Programming the ENIAC was a laborious task. Forget keyboards and monitors, operators interacted with the machine through a labyrinth of cables and switches. Each calculation required a specific configuration of these physical connections, making the process time-consuming and prone to errors. Yet, despite its limitations, the ENIAC was a marvel of its time. It could perform thousands of calculations per second, dwarfing the capabilities of even the most skilled human calculators. The impact of the ENIAC was immediate and profound. Originally designed to calculate artillery firing tables for the war effort, its potential quickly became apparent in other fields. Scientists and engineers embraced this new tool, using it to design bridges, predict weather patterns, and even model the detonation of the hydrogen bomb. The ENIAC, for all its shortcomings, had ushered in a new era, the age of the computer. The reign of the vacuum tube, while groundbreaking, was destined to be short-lived. Bulky, fragile, and power-hungry, these glass tubes represented a technological bottleneck. The solution arrived in the form of the transistor, a tiny semiconductor device invented in 1947 at Bell Laboratories. This seemingly simple invention, smaller than a fingertip, would revolutionize the world of computing. Transistors could perform the same functions as vacuum tubes, but were exponentially smaller, more efficient, and more reliable. Computers built with transistors could be significantly smaller and more powerful than their predecessors. This miniaturization also led to a decrease in cost, making computers accessible to a wider range of institutions and businesses. The second generation of computers powered by transistors also witnessed the rise of programming languages. No longer were programmers confined to the tedious and error-prone world of physical switches and cables. Instead, they could now write instructions in symbolic languages that were then translated into machine code. This development made programming more accessible and efficient, paving the way for the development of sophisticated software applications. The invention of the integrated circuit in the late 1950s marked another seismic shift in the evolution of computers. Often referred to as the microchip, an integrated circuit combined thousands of transistors and other electronic components onto a single piece of silicon. This miniaturization on an unprecedented scale led to a dramatic increase in processing power and a corresponding decrease in size and cost. The third generation of computers, powered by integrated circuits, ushered in the era of mainframe computers. These powerful machines, while still large and expensive, could now be used by multiple users simultaneously. Time-sharing operating systems allowed for efficient allocation of computing resources, making it possible for businesses and research institutions to share a single machine for a variety of tasks. This period also witnessed significant advancements in user interaction. Keyboards and monitors became standard input and output devices, replacing the punch cards and printouts of earlier generations. The development of graphical user interfaces, GUIs, made computers more intuitive and user-friendly, paving the way for the mass adoption of personal computers in the decades to come.